Alright, so here's a video for 8.6, the empirical rule. And the empirical rule is for normal distributed data values. So the population has to be normally distributed. And the values are 68, 95, and 99.7. Those are the three numbers that you need to have it in your mind every time you hear the empirical rule. 68, 95, 99.7. Okay? I'm going to do problems number 3 and 4 from your worksheet 6. But first we need to understand the empirical rule. Where does this number fit in the empirical rule? So I printed a empirical rule here from the internet. I just found a blank empirical rule so I can help you fill it out. The numbers that I need to remember is, I'm going to write it right here on the top, is 68, 95, 99.7. Those are the three numbers I need to remember. How does these three numbers fit in my empirical rule? If I have a normally distributed data value, okay, population, it has to be normally distributed. That is a prerequisite for me to be able to use the empirical rule. They must be normally distributed. It must be a normally distribution, okay? So once I have anything, a population values, information that is normally distributed, I can use the empirical rule. The empirical rule tells me the mean is right in the center, and within one standard deviation from the mean, and you need to understand what a standard deviation is, within one standard deviation of the mean, we have 68% of the values of my data. Okay, so 68% of the values are within my one standard deviation from the mean. That means I can add one standard deviation, subtract one standard deviation, and within those values, I'll have 68% of my data values. And that means that the mean is splitting things in half. And splitting 68 in half gives me 34% that are above the average here, above the mean, and I have 34% that is one standard deviation below the mean. So that's how you need to see that 68 value. So that is my 68, that's where it came from, okay? Now, 95 tells me the second value tells me 2 standard deviation. So within 2 standard deviation, okay, within 2 standard deviation, I have 95% of the data values of my normal distribution. So 95%, but I already have 68. So you have to do a little bit of math on your mind there. If 95, it is within 2 standard deviation, but I already covered 68% of that area, then what do I have left? 95, so let's do a little math here on the side. 95 minus my 68 gives me 27%. When I grab that 27% and divide it by 2, we get 13.5. That means I need to put 13.5 here on this side and 13.5 here on this other side. And these are all percentages that we're dealing here under the curve, okay? Does that add up to 95%? I guarantee you it does. 13.5 plus 13.5 plus the 68 in the middle adds up to 95%. So within 2 standard deviation from the mean, I have 95% of my data values, okay? Now that is the second number. Now the third number, so third number tells me 3 standard deviation. So within the 3 standard deviation from the average, from the mean, I will have 99.7% of my values. So 99.7, we already did here a little math, we need to do another one. So 99.7 minus the 95% that I already covered gives me the leftover of 4.7. When you grab 4.7 and you divide it by 2, because you need to split it between 2 sides, we will get 2.35. So I know that here I have 2.35% and here I have 2.35%. So that is how we distribute these 3 values among our under the curve. Now, what happens to this teeny little amount, very, very small little amount that I didn't count? We say that under the curve, you'll have 100% of the values. We want to have all 100%, all the values accounted for. Those are the values that are extremely rare, are the values that are above 3 standard deviation above the mean, and values that are 3 standard deviation below the mean. So if you really want to know what this little teeny percentage is right here, this little teeny percentage, then you have to do a little bit more, a little bit more calculation. Then you grab 100% minus your 99.7, which equals 0.3, 0.3, and then when you divide it by 2, you get 0.15%. So that is what is left over right here, is 0.15%, 15%, and here is 0.15%. So now I kind of accounted for all of the curve, even though this curve never really touches it, the x-axis here. So we are more concerned with the 99.7%. We are more concerned with values that are within 3 standard deviation above the mean and 3 standard deviation below the mean. But it does not hurt to account for this little teeny percentage of values that are above 3 standard deviation and below 3 standard deviation. Okay? So that is where this 3 values of the empirical rule gets fit here under the curve for a normal distribution. Now, my students ask me all the time, do I have to memorize these values? Do I have to memorize these values? You choose. You either memorize these 3 numbers and how to fit in the curve, or you memorize these 3 percentages here, 34, 13.5, 2.35, and then you repeat here on this side, and then you can go ahead and get your 0.15 here, okay? So somehow you need to have a little bit of memorization. It's good for your brain, and also understand where these values came from. Preferably, I would not memorize these values here under the curve. I would understand what the 68, 95, and 99.7 means. This means I have the 68% of the data values are within 1 standard deviation, 95% of the values are within 2 standard deviation, and 99.7% of the values of my data are within 3 standard deviation. Okay? That's what it means. So being above the average 1 standard deviation, being above the average 2 standard deviation, or being below the average 1 standard deviation is important to know what that means, okay? Not just memorizing numbers. Now that we have an idea what that means, why don't we go ahead and solve problem number, let's see here. Let's take a look at your worksheet for the empirical rule, worksheet 6. Let's go ahead and solve number 3, shall we? Let's read carefully what it's saying, and let's go over the answers. All right, let me zoom in a little bit. How do we use the empirical rule? All right. Okay, here we go. So let's read the word problem carefully and then gather information and then see if we can use the empirical rule. All right, so it says 600 juniors at Union Prep Academy took the ACT last year, the ACT test. The scores were distributed normally with a mean of 22 and a standard deviation of 4. Label the mean and 3 standard deviations from the mean. Let's gather up the information. It says that I had 600 juniors. Okay, so N equals 600. And then it tells me the scores were normally distributed. That's good because I need a normal distribution. So normal distribution, check. Because it's normally distributed, I can use those percentages under the table, the same ones that we just derived it. Because it's normally distributed, I can use the empirical rule. That's what gives me the right to use the empirical rule. So I have 600 students. It is normally distributed. I have the mean, so mu equals 22. That's the average of the scores. And the standard deviation, which is 4. Now they want me to label the mean and 3 standard deviations from the mean. The mean always takes place, because it's normally distributed, it will take place right in the center. Let me go ahead and split the data right here, and my 22 goes in the middle. And then I'm going to go up 1 standard deviation, 2 standard deviation, and 3 standard deviation. I'm going to go down, subtract 1 standard deviation, 2 standard deviation, and 3 standard deviation. Okay? So 22 plus 4, because I'm moving up 1 standard deviation, is 26, plus 4 more is 30, plus 4 more is 34. Okay, so that's how I moved up 3 standard deviation. And then 22 minus 4 is 18, 18 minus 4 is 14, and 14 minus 4 is 10. So if you scored 10, you are 3 standard deviation below the average. If you scored a 30, you are 2 standard deviation above the average. So perhaps this is my mean, this is 1 standard deviation, this is 2 standard deviation, and this is my 3 standard deviation, okay? And then going in the negative direction, I subtracted 1 standard deviation, subtracted 2 standard deviation, and subtracted 3 times the standard deviation. That's what those values mean to me. Now, because it's normally distributed, the empirical rule gives me those percentages. I can use exactly the same ones. I memorize them to be 34% here, 13.5% here, and then right here, there's no room, I'm going to write outside, 2.35% here, and then you have, if there's any person that scored above 34, you would be considered the 0.15%. Okay? And then I can repeat exactly the same values to the left. 34% here, 13.5% here, and I'm going to put it outside, the 2.35% here. And then if anybody scored below 3 standard deviation, below the value of 10, you would be considered the 0.15% of the data value. Right? I like all my numbers there, all my percentages, everything is labeled perfectly. Now I can answer the questions from these values. I have to do almost zero calculation because all of the answers are going to come from these values over here. What percentage of scores are between 18 and 26? Well, between 18 and 26, they want a percentage. That would be 34%. Okay? 34% of 600 students score between 18 and 22. What percentage of scores are between 14 and 30? So 14 all the way up to 30, that is 2 standard deviation. 2 standard deviation above and 2 standard deviation below. And the 2 standard deviation is my 95% rule. Remember, the rule was 68 is 1 standard deviation, 95 is 2 standard deviation, and 99.7 is 3 standard deviation. So what percentage are between 14 and 30? If you add 14 all the way to 30, the percentages under the curve will add up to 95%. So I get 95%. What percentage of scores are between 14 and 26? So 14 and 26. So now I'm adding the percentages. I cover everything else. I'm only adding from 14 to 26, and that is 68, right? 34 plus 13.5. So when you add all that up, you get 81.5. Okay, 64 plus 64 plus 13.5 gives you 81.5. Now, what percentages, I'm still talking about the percentages under the curve, is less than 14. So less than 14, just mark, everything else here is covered. So less than 14 would be 2.35% plus this 0.15%. So if you add 2.35 plus 0.15, you get 2.5%. Okay? Now, what percentage of scores is greater than the score of 22? Well, 22 is my mean. To be greater than my mean, if I add up all this percentage, it adds up to 50%. Because my mean divides the curve perfectly in half. 50% on the top, 50% on the bottom. So what percentage of scores are greater than 22, which is my mean, that would be 50% of the data. Now we're no longer asking what percentage. Now we're asking how many, okay? So whenever it says how many, I need to think of my 600 students. How many of my 600 students, of my 600 juniors, scored between 22 and 26? Well, between 22 and 26, we have 34%. But I'm not asking percentage, I'm asking how many. So I have to do 34% of 600. The way to calculate that is to turn 34% into 0.34, that is still 34%, times my 600 students, because I want to know how many of the students. So 0.34 times 600, if you do that in your calculator, you get 204 students. Okay? So how many juniors score between 18 and 26? Let's take a look at it. Between 18 and 26 is 1 standard deviation. I have 68% of the students. So that means I have to find out how many is 68%. So 0.68 times my 600 students. 68% of 600 students, if you do it in your calculator, you get 408 students. That's how many students score between 18 and 26. It's a lot of students. It's 68% of 600. How many juniors scored between 22 and 30? So between 22 and 30, you need to come and find the percentage. 22 is the average, and 30 right here. If you add 34% plus 13.5%, you get 47.5. So 0.475 times my 600 students, that is, if you do it in your calculator, you get 285. Let me check it. I don't want to give you a wrong answer here. Let me see, 0.475 times 600 students, 285. 285 students score that high, okay? Now, 285 students were above the average, okay? Average or above, that's pretty good. How many juniors scored between 14 and 18? Between 14 and 18, there's only one percentage, which is 13.5. So I'm going to do that. 0.135 times my 600 students, and that gives you 81 students. Make sure you do that in your calculator. And the last one is approximately how many juniors scored lower than 30? Lower than 30. That means all of these percentages right here. You can either add them all, or I think of everything under the curve is 100% minus this tiny little amount here, 2.35 plus 0.15, which is 2.5. So 100 minus 2.5, or you can just go ahead slowly, no big deal, add up all these percentages right here, including this very, very last little tip, and you get 97.5%. 0.975, that is all those numbers less than 30%. I'm sorry, let me repeat that again. Is all those percentages that are less than 30, the score of 30, and then you multiply it by 600, and you get 585 students. So you can, less than 30, I add up all these percentages, and I got 97.5%, and that's how I turn into 0.975. Okay? And that is how you find out the difference between how many versus percentage. Okay? And that is how you use the empirical rule. The empirical rule, if it is normally distributed, we can use exactly the same percentages of the empirical rule, and that's what it means, the 68, 95, 99.7, how to use it. All right? So I hope you understand it, and I hope you know how to derive these numbers, how it fits into under the curve, and then you can answer any problem. Okay? So taking a look at problem number 4, I can kind of get you started, but I am not going to do all the questions because it is exactly the same the one I just did it. So we have 150 customers. So I know that I have 150 total people. They bought lunch at the food court. The amount to spend were distributed normally. Because it is normally distributed, then I can use those same exact percentages, 34, 13.5, 2.35, and 0.15, okay, is the empirical rule percentage. Is the 68, 95, 99.7 rule, okay, because it's normally distributed. With a mean of 5.50, so that mu, the mean is 5.50, and the standard deviation is of 0.50, okay, 0.50 cents. So now it says label the mean and the 3 standard deviations. Because it's normally distributed, we have a nice check mark. I can go ahead and break the mean goes right in the middle, and the mean is 5.5, or if you want to put 50 is okay. Here's 1 standard deviation above, 2 standard deviation above, and 3 standard deviation above. And here's subtracting 1 standard deviation, subtracting 2 standard deviation, and subtracting the 3rd standard deviation. So if I'm going to add 50 cents to 550, I'm going to have 6.00 if you want to do that. And then if I add 50 cents more, I'm going to have 6.50. And if I add 50 cents again, I get a 7.00. If you subtract 50 cents from 550, you get 5.00. Subtract 50 cents again, you get 4.50. And you subtract 50 cents again, and you get a 4.00. And that is adding and subtracting the standard deviation, okay? So this is my mean. This is adding 1 standard deviation. This is adding 2 times the standard deviation. And this is adding 3 times the standard deviation. Here is subtracting 1 standard deviation from the mean, subtracting 2 standard deviation, and subtracting 3 standard deviations, okay? 3 times the standard deviation. The percentage under the curve are the same because it's normally distributed, so I can use the empirical rule, 34% on each side, and then 13.5, and then 2.35 I'm going to put on the outside, 2.35%, and the last little tiny bit right here is 0.15%. You can repeat exactly the same thing here on the left, 13.5%. On the outside right here is 2.35%, and on this little tiny amount here is 0.15%. So I have all the values in front of me, everything is perfect. I can answer any of these questions. What percentage of students are between 450 and 6? So 450 and 6, go ahead and add those percentages. Make sure you stop right where your boundary is. Anything that is not within 450 and 6, I add those percentages right there. I will let you go ahead and do those answers because it's pretty much either looking at percentages, and then after that is looking at how many. So you're going to follow the same process I just did in the previous example, okay? Good luck with using the empirical rule.